Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Okay, good day, students. How are you all doing? Welcome to today's class. In today's class, we shall be talking about differentiation. We shall focus on two different methods of differentiation, which are product rule of differentiation and implicit function. And I'll be talking about how to apply product rule of differentiation in implicit function. All right. What is product rule? Product rule is just like a mathematical statement or a rule or a formula that is used to find the derivative of a function, okay, that contains two or more other functions multiplied together. That is product rule, meaning that I can have a function like this, y equals to what? AB. Okay, to find the derivative of this function that contains other functions, two or more functions that are multiplied together, is called what? A product rule. And the rule is saying that if we are given y equals to AB, the rule says the y dx, which is called the derivative, which is equals to a db d what? Dx plus b dA over what? Dx. This is the product rule of differentiation. This is what the rule is saying. The rule is simply saying that if I have a function that has a product function, all right, okay, or a product function, to find the derivative of a product function is simply dy dx equals to keep a constant, meaning don't differentiate a, differentiate b, plus don't differentiate b, differentiate a. So this is being read as a db dx plus b dA dx. This is what product rule is stating. All right. Then what is an implicit function? A function is implicit when both the independent and the dependent variable are clustered on one side of the function, meaning that I can have a function whereby both x and y are not acting as subject of the function. That is called an implicit what? Function. All right. So I repeat again, a function is implicit when x and y, when dependent and independent variable of the function are either clustered together on one side of the other in such a way that one of the function is not acting as a subject of that function. For example, if I have a function like this, I have x squared plus what? Y squared equals to what? 100. This is a good example of a circle, right? This is a circle. Okay. If I have a function like this, x squared y plus 4xy plus x squared equals to 100. Okay. What you notice here is that both x and y are clustered together by multiplication, meaning that they are not acting as a subject of a given function. If I have a function like this, y equals to, let's say 2x plus 4, or y equals to x squared plus 5s plus 6, or y equals to 2x cubed plus 4x squared plus 7x plus 9. These functions here, these three functions, they are called explicit function. Explicit function. In explicit function, we have y acting as a dependent variable. Y is acting as subject of the function with respect to x. But in this case here, both x and y are acting, they are being clustered together. None of them is acting as a subject of the function. They are just together, like we just saw. X squared plus y squared equals to what? 100. Or we have x squared y plus 4sy plus s squared. Whenever you see a function like this, whereby x and y are not acting as a subject of that function, or x and y are being clustered together in one side of the function, okay, we call that what? An implicit function. So if I have a function whereby y is acting as a subject of the function, we call that explicit what? Function. Another example for explicit can be of this kind. If I have y equals to, let's say, x cubed plus 4x divided by 2x plus 5. This is also an explicit word function. In this function here, y is acting as a subject of that function. Okay, so this is one of the ways to differentiate implicit function from explicit function. Then we have seen that for a product rule is a mathematical statement or a rule or a formula which is used to find the derivative of a function that has two or more functions multiplied what together, like we just saw, y equals to ab, right? Y is a function. Y contains two functions that are multiplied together. Okay, an example of product tool can also be y equals to, if I have a function like this, s squared times s cubed plus 6x all squared. Okay, this is also a product function in the sense that here, if you look at this closely, you can tell that s squared represents a, right? Why this function represents what? B. Okay, so we shall be looking at how to apply product rule of differentiation in implicit function. One thing you should understand is, before you can fully understand how to differentiate implicit function, you must have to understand product rule. Looking at this now, I have s squared y plus 4sy plus s squared. Okay, to differentiate this, I have to apply the principle of product rule. Looking at it, we have s squared y. S squared represents a, y represents what? B. 4s can be taken as a, y can be taken as b. Are you there? Then this, I will differentiate using the power rule of differentiation. Okay, in my previous class, we have learned how to differentiate with the use of power rule of differentiation, right? Where we say that if we are given a function of this kind, y equals to ax to the power of n, the rule says that dy dx becomes what? I'll multiply the power with the coefficient of this s, right, which is a, then subtract 1 from the power. That will give us nax to the power of n minus 1, right? A good example of this is that if I have a function like this, y equals 2x to the power of 4, and we have to find the derivative of this function, which is called dy dx, that will give us 4 times 2, will give us 8x. Then the rule says subtract 1 from the power, which is 4 minus 1. Then the answer becomes 8x to the power of 3. Okay, this is called the power rule of differentiation. The power rule of differentiation. But today's class, my emphasis will be strictly on product rule and its application to implicit function. Meaning, I'll be doing two different differentiation today. I'll be differentiating product function and implicit what? Function. Okay, so let's continue. Okay, let's look at this question. Before we solve this, I want us to remember something. Let's recall that we are told that if y is equals to ab, the product rule says what? The y, the x, which is the derivative of y, right, with respect to x. The y, the x will give us a db dx plus b dA the what? The x. This simply means we'll keep a constant. Meaning don't differentiate a, differentiate b, meaning db dx, plus don't differentiate b, differentiate a. Okay, in this case, this is our a, right? This is our b. Now let's go. Now applying the rule, product rule, this will give us the y dx is equals to, I will keep a constant, right? I mean, I will not differentiate a, which is my s squared plus 3. Then I will differentiate b. Differentiating b, I will use the power rule of differentiation. So I'll multiply this 3 by 1. Quotient of x here is 1, right? So 3 times 1 is 3. Then I'll subtract 1 from the power. If I'm to differentiate s cubed, the rule says multiply 3 by the coefficient of this x, which is 3x. Then we'll subtract 1 from 3, which is what? 2. So that will give us what here? We're going to have 3s squared, right? Minus, when we differentiate 2x, the power of 2 of x is 1. Multiply 1 by 2, we have 2x, right? We subtract 1. Don't forget the power rule of differentiation. That gives us 1 minus 1. So we have 2x to the power of what? 0. This will give us 2 times 1. The answer becomes 2. X to the power of 0 is 1. So we have 2 times 1 will give us 2 there. So that means when we differentiate minus 2x, we're going to have here as what? As minus 2. The rule says after working on this side, we have to add what to it? Plus. Don't forget the rule of differentiation. Y equals to AB. We have the y dx becomes a db dx plus b dA dx, right? Meaning keep a constant. Differentiate b, which I've done, right? Which I've done. Then plus, we keep what constant now, this time around? B. It means I will not differentiate b. What do we have as b? b is s³ minus 2x. Then the rule says after keeping this constant, we have to differentiate what? A. So let's differentiate A. When differentiate s² plus 3, this will give us 2x. Differentiate constant. Anytime you differentiate a constant value, 3 is a constant value, the result must be equals to 0. The derivative of every constant is equals to 0. So when differentiate s² plus 3, the result becomes what? 2x. So we have 2x here. So what do we do next is to multiply or expand. So my dy dx becomes s² times 3s² will give us 3x to the power of 4. 3 times 1 is 3. S² times s² is what? Is s to the power of 4. So let's multiply again. We have multiplied s² by this. Let's multiply s² by what? Minus 2. That will give us minus 2s², right? Then I'll multiply 3 by 3s². That will give us 9s². Then multiply 3 by minus 2. That will give us minus 6. Then we have here as plus. Yeah, I'm going to expand this. I'll multiply 2x with s², s³, and what? Minus 2x. So 2s times s³ will give us 2x to the power of 4. 2s times minus 2s is minus 4x to the power of 2. Okay, we have like terms here. This and this are like terms. So that means my dy over dx becomes 3s to the power of 4 plus 2s to the power of 4. That will give us 5x to the power of 4. Then here we have another like terms again. We have this and this are like terms. Also with this, right? So let's go. Minus 2s² plus 9s² will give us 7s², right? 7s². Then 7s² minus 4s² will give us 3s². So we have plus 3s². We are left with minus 6 here. Final answer, minus 6. This is the final result. Let's see example 2. Okay, example 2 says, given that y equals to 6x times s² plus 2, we also find the y dx using product rule. Please take notes, using product rule. They didn't say using power rule. Although I can decide to expand this, right? 6s times s² give us 6s to the power of 3. Then 6s times 2 give us 12x. Then I will use my power rule to differentiate. So the question says using product rule, we have to use product rule of differentiation. Are we there? So let's solve with this. So solution, remember our rule that says that if y equals to product of a and b, to find our derivative of the function, we use the y dx equals to, we keep a constant, a db ds plus keep b constant, b dA dx. All right, so let's do the same thing here. In this case here, this is my a, this is my b, right? So let's go. So this will give us, here we have our dy dx, which is equals to, we keep a constant, we have 6x. Differentiate s² plus 2. When differentiate s², we have 2s. Differentiate 2, we have what? 0. So that means here will give us 2x. So we have plus. We keep what constant now? We have to keep s² plus 2 constant, right? Then we differentiate 6x. We have 6 here. So by the time we multiply this out, this will give us 6s times 2s will give us 12x squared, right? Plus 6 times s² will give us what here? 6s² plus 12, right? 6 times s² is 6s². 6 times 2 is 12. So these two are like terms, so they can be added together. So this will give us about 12x² plus 6s² is 18s² plus 12. This is our final answer. So my dy dx is equals to this. I have a question that says that we are given that y equals to s to the power of 4 sine x. Find the y dx. This is also a product. Look at this here. If you look at it, we have a product here. This is my a. This is our a. This is our b. Okay. Don't forget that in a table of differentiation, I gave us some values that if we have our y and we have to find our dy dx, sometimes we use y prime to represent the y dx, or we also use f prime of x, right, to represent the y dx, or we also use the y, the what? The x. So we say that if we have x to the power of n, right? Or is, let's say, ax to the power of n, our derivative becomes nax to the power of n minus 1, right? If we have exponential x, it remains as exponential x. If we have exponential kx, it remains as k exponential kx. If we differentiate sine x, we're going to have cos x. If we differentiate cos x, we're going to have minus sine x. Please take notes. And if we differentiate tan x, we're going to have sec square x. We have many of them. As this class proceeds, I'll be showing us. If we differentiate ln x, we're going to have 1 over x, and so on and so forth. There are many of them. This is just a simple differentiation table, all right? So the reason why I have to bring up this because of this function here, sine x. So it means that anytime we are to differentiate sine x, I will replace that with what? With cos x. So the derivative of sine x is cos s. The derivative of cos s is minus sine s, the reverse of it, but with a negative sign, right? So let's go. So from the principle we have, which is this, so let's go. Our dy, the x will be, I'll keep a constant. I'll keep this constant, x to the power of 4. I'll differentiate sine x. The derivative of sine x is simply what? Cos x. So when you differentiate sine x, we're going to have here as cos x. So plus, they will say put a plus sign. Then we keep what constant now? We keep sine s constant. Then we differentiate s to the power of 4. That will give us 4x to the power of 3. Don't forget, the rule says when you differentiate this, multiply the power by the coefficient of this x, then subtract 1 from the power. So 4 times 1 remains 4. Then when we subtract 1 from 4, we have 3. Okay, so this will give us our dy, the x, which can also be replaced as y prime, right? Also be replaced with f prime of x is equals to x to the power of 4 cos x plus 4x to the power of 3 sine x. Okay, then we can look at these two terms together. Since we have a plus sign here, I think we have something that is common. A term is common here. X to the power of 3 is common. Here we have s to the power of 4. Here we have s to the power of 3. So I can actually factor out x to the power of 3. If x to the power of 3 is common in these two terms, when divide the whole of this with this, we're going to be left with x cos x plus, when divide the whole of this with this, we're going to be left with 4 sine x. Final answer. This is the final answer here. All right. So this simply represents the y, the what? The x, which can also be represented with y prime of or f prime of x, right? Okay. All right. We have a question that says that given y equals to x squared exponential x, find the y, the x, right? Solution to this. This is very simple as well. Yeah, our x squared represents our a. This represents our b, right? So let's go. So formula says the y, the x equals to this, right? This is a formula here. So let's apply it. We keep a constant. This becomes our a. It means don't differentiate a, right? So I will differentiate b, the b, the x, meaning differentiating exponential x. In the table of differentiation, we say that when we differentiate exponential x, it remains the same. It does not change. So here we have our ex, right? Ex. So when we keep this constant, differentiated this, we have this. The rule says plus, right? In the second aspect, I'll keep b constant. It means I'll keep this constant. Then I'll differentiate x squared. This will give us what? 2x, right? So let's go. So my dy, dx becomes, okay, we have here as x squared exponential x plus 2x 2x exponential x. Okay, I think this can be expressed as this. Between these two terms, what is common is x, right? X is common in bracket. Here we are left with x exponential x plus 2 exponential x. This is the final answer to this. Okay. This question says find the y dx using product rule of differentiation. Okay, this is simple. This is very simple. So let's look at this. Here we can take this as our a, right? Take this as our b. Y is the product of two functions here. In fact, three functions. We have 5 times this, abi. We can take 5 as a function. We can take this as a function. It's also as a function. But in this case here, to solve, I can group them. Since in product rule, we are only concerned about just two functions, right? Even though we have 3, I have to look out for a means to group them into 2. So yeah, I can group these 2 together as one, as A. Then group this as what? As B. So let this represent A, this represent B. Okay? I can also group 5 and sin x as B. Then group only this as what? As A. But let me just take it in this order, since this is the order that was given to us, right? So let's go. Now, what we do here is to apply the rule. The rule says the y, the x equals, the rule says we keep A constant, 5 exponential 4x. Then differentiate sin x. When we differentiate sin x, the result is cos x, right? We're going to have cos x here, cos x. Then plus, they will say we keep b constant, right? Meaning don't differentiate b. We have sin b. Differentiate 5 exponential. Whenever we have a function like this, 5 exponential 4x, and we have to differentiate this, all right? Look at this rule here. Here we have e exponential kx. The result said k exponential kx. I want to show us something. Let me take us through a journey. Please take notes. I'm coming back to this. If y is actually giving us exponential 4x, from this principle here, ks simply means, a good example of this is this, right? Here our k is 4. Then the rule says k exponential ks. That means that to differentiate just this is simple what? The y dx to give us what here? Simply, okay, 4 exponential what? 4x. Since the general rule of this says exponential ks will give us k exponential ks. So if I have exponential 4s, what will it be? 4 exponential 4s, just like we have here. Exactly. But in this case, I have a number here attached to exponential. Whenever you have a number, just a constant. What I mean by a constant, a number without a variable, just like 5. Okay? I can just decide to multiply this 5 with this 4 here. So this becomes, to differentiate this, it simply means our dy, dx equals to 5 times the derivative of exponential 4x is 4 exponential 4x, right? And that will give us what here? 20 exponential 4x. So that means when we keep this constant and differentiate this, the answer is 20. For this alone, just this, the answer is 4 exponential 4x. So that 4 times 5 give us 20, right? So we have here as 20 exponential 4x. Please don't forget. So let's see how we can expand this together. Let's expand together. Let's expand and see. Yeah, we're going to have here as the y dx to be equals to, here we have 5 exponential 4x cos x plus 20 exponential 4x sin x. When we look at this closely, we have common terms here. 5 is common here. 5 is common here, right? Exponential 4s is common here. Exponential 4s common here. So I can factor out 5 exponential 4x in brackets. If this is common in these two terms, when you divide the whole of this with this we cancel it, right? Remaining what here? Remaining cos cos x plus, when we divide the whole of this 20 exponential 4x sine x with this, definitely this will cancel out this. 20 divided by 4 by 5. 20 divided by 5 will give us what here? 4. Right? Yeah, we're going to have 4 sine x. This is the final answer here for this expression. This is very simple. Let's look at the next question. I have a question that says that if y equals to 4s cos 4s squared, and we have to find the y dx using product rule of differentiation. So yeah, we can see that. We can say let our a, right? Let a equals to 4x, and definitely b will be cos 4s squared, right? So we can then differentiate. That will give us what? The y dx equals to, we keep a constant, meaning don't differentiate a, differentiate cos 4s squared. Now look at this. If I'm to differentiate cos x, the result says minus sine x. Okay, let me show us something how to differentiate this. Here we have, let's say if we have y equals to cos 4s squared, we can use the principle of chain rule method to differentiate. But since I've not taught chain rule, let me just use the power rule of differentiation. There's a principle I will use now to differentiate this. Listen, we have seen that we have to keep this constant, right? Then differentiate this. But the challenge is, how can we differentiate cos 4s squared? Knowing that differentiation of cos s give us what? Minus sine x. So let's go. So this will give us what? The y, the x, watch. This will give us, bring us to minus sign first. Minus. Differentiate this 4s squared. That will give us what? 8x. Then differentiate cos. That should give us what here? Sine. Then I will repeat this again, which is 4s squared. Let me explain again. We already know that anytime we differentiate cos, we must have a negative answer, negative sine x. So the first thing is to bring out that negative value. Then differentiate what you have here. Okay? This function 4s squared. We have this as what? As 8x. So when differentiate 4s squared, we have 8x. Then I have to bring out my sign, because differentiation of cos will only give us sine. So we have minus 8s sine 4s squared. Just repeat whatsoever you have here, and that will give us what? Minus 8s sine 4s squared. So after keeping this constant, when you differentiate this, the result will be minus 8x sine 4s squared. All right, okay, that's for this. Then plus, we keep what constant now? We're going to keep cos 4s squared constant, cos 4s squared constant, then differentiate 4s. That will give us 4. Okay, that will give us 4. Where's our duster? Okay. So let's multiply this out. So our dy over dx, 4x times minus 8s, we have minus 32, right? S squared. Okay. Sine 4s squared. I'll repeat again. 4s times minus 8s is minus 32s squared. Then I have my sine 4s squared, right? Plus 4 times cos 4s squared will give us 4 cos 4s squared. Are we there? Okay. Then another thing is to look out for what is common between this term. I guess 4 is common. That will give us, here we have the y, the x, give us 4 is common here. We have 4 in bracket. So here we have 4 times 8. When we divide the whole of this here with 4, that will give us minus 8, right? 8s squared sine what? Sine 4s squared plus cos 4s squared. Final answer. You can put this down. Okay, we are given a function here to differentiate using product rule. Then here we are given ln x sine x, right? So let's go. Let's see what will be the result of this. Here we have the y dx give us, we keep ln x constant, right? We have our ln x constant, differentiate sin x. That will give us cos x. Of cos x, right? Okay. Plus, we'll keep sin s constant, then differentiate ln x. We say when we differentiate ln x, we have 1 over x. We have 1 over x. So this will give us dy dx equals to, here we have ln x cos x plus sin x times 1 is sin x divided by x. So this is the final answer here for this. Just simple, very simple question. Okay, this is just the final answer for this. All right, so let's see another question. If we are given s squared plus y squared equals to 1, and we are asked to find dy dx. If you're given such kind of function, if you look at this function, you notice that both x and y are squared and they are both clustered in one side of the function, right? Both x and y are not acting as subject of the function. So this is a good example of implicit function. But how do we differentiate implicit function? To differentiate using implicit function, anytime you differentiate y, please, you always add dy dx. I repeat again, in implicit differentiation, anytime we differentiate y, we have to add dy dx to it. Only y. So let's look at this. So solution is that, let's differentiate. I will differentiate each of these using the power rule. The power rule says if we have y equals to ax to the power of n, so dy dx, this is what the power rule is saying. A good example is that if we have y equals to 2x to the power of 4, so using the power rule, we have dy dx will give us 4 times 2 is 8x to the power of 3. So for this, I will differentiate each of these terms. But anytime we differentiate y, we have to multiply what we have with dy dx, or we just add up dy dx to it, okay, to that term. Now let's see. Solution to this, let's differentiate x squared. We have 2x plus differentiate y squared. We're going to have 2y. So I'll multiply by dy dx. Are you seeing it now? So here we differentiated x squared. We have 2x. Differentiate y squared. Just add what to it. Add your dy dx to 2y. Anytime, this is the rule of implicit differentiation, that anytime we differentiate y in the function, multiplied the result with what? Dy dx. Okay, then all equals to 0. When you differentiate 1 is a constant. Every constant have a derivative of 0. So when you differentiate 1 being a constant, the result is 0. Okay, so what do we do here is to make our dy dx to become the subject of the formula, right? So it means I'll move these 2s to the other side of the equation. Then we're going to be having here as 2y dy dx equals to minus 2x. Okay, now our job is to make dy dx to stand as a subject. So what we do here is to divide both sides by what? By 2y. Divide both sides by 2y. So here, 2y can cancel 2y. Then we are left with dy dx, which is now equals to, in this case, 2 can cancel 2. We are left with minus x divided by what? Y. This is just how to differentiate using implicit differentiation. Okay, let's see another example. If we have x cubed plus y cubed, we are given x cubed plus y cubed equals to 6x equals to 6x. So 6xy equals to 6xy. Here we are asked to find dy dx. So let's differentiate this and see solution to this. This is also a good example of implicit differentiation. Here, both x and y are not standing as the subject of this function, right? They are clustered together. You can notice x and y here. The power of x is 3. Here we have 6sy clustered together. So let's see how we can differentiate this. Don't forget the rule that says that anytime we differentiate y, we multiply the result with dy dx, or we just add up dy dx. In this case, look at this side, the right hand side. If you notice, we have 6sy. This is, I'm going to use product 2 here to differentiate this. I can either pick this 6x as A, then pick y as B, or pick 6y as what? As A, then x as what? As B. But I think the best is to pick 6s as A, then y as B. But on this side, I'm going to use power rule to differentiate. Then here I will use my product rule to differentiate. So let's go. So that will give us differentiating s cubed. We're going to have here as 3s², right? 3 times 1 is 3. Subtract 1 from 3, we have 2. Plus, here we have 3y². The rule says, after differentiating y, we multiply with what? The y dx. Don't forget. Then here we have equals to. Then on this side, I'm going to apply the product rule that says that if y equals to ab, the rule says we keep a constant, meaning the y dx, a db dx plus b dA dx. It means I'm going to keep a constant. Since we are choosing 6x as A, then y as B, it means I'll keep 6s constant, differentiate y. When differentiate y, what we have is 1. But because I'm differentiating y, the rule says I'll multiply with what? The y dx. Don't forget. So plus, I'll keep what constant? B constant. Y is my B. Then I'll differentiate what? A, which is my 6s. And that will give us 6, right? So let's go. So let's see what will be the result here. Let's go. We keep this constant. We are taking this as A, right? We keep 6s constant. Differentiate y, we have 1, right? Because we differentiated y, the rule says multiply with what? Divide the what? The x. In product 2, after evaluating this, there's a plus sign, Abi. Let's bring it out. So in this, in the other side, we're going to keep what constant now? We keep y constant, right? Then differentiate 6x. That will give us what? 6. Don't forget that anytime you differentiate y, that's when we multiply with the y dx. But anytime we differentiate x, don't multiply with the y dx. In this part here, we differentiated 6x, and that gives us 6. We differentiated s cubed. We have what? 3s². But whenever you differentiate y, we multiply with the y dx. So let's move on. So in this case, so let's see. We're going to have it as 3s² plus 3y² dy dx equals to 6s times 1 will give us 6x dy dx plus 6y. So I'll collect like terms. It means I'll bring these two together as like terms because I'm looking for dy dx. We have to solve for dy dx. So definitely I'll bring them together as like terms. So, and I'll move this to this side. So let's bring this to this side. That will give us 3y² dy dx minus 6x dy dx equals to, we are left with 6y here. We'll move 3s² to the other side. It becomes minus 3s². Since we are looking for dy dx, it means I'm going to take dy dx as a common factor here. That's dy dx is common. All right. Okay. Although between these two, not just only this that is common, 3 is also common. But our goal is to solve for dy dx. So I'll factor it out as a common factor. So if dy dx is out, what will remain here is definitely 3y², right? Minus what? Minus 6x. All equals to 6y minus 3s². Now let's finish up this. To solve for that, how do we solve for dy dx? I have to divide both sides by this term, by 3y² minus 6 by 3y² minus 6. So let's go. So this, we cancel out this. We are left with dy dx. We are left with dy dx, which is equals to 6y minus 3s² divided by 3y² minus 6. Okay, 3y² minus 6. Sorry, this should be over 6x, right? Minus 6x. Sorry, minus 6x. Because we divided, what we have here is minus 6x, not minus 6, minus 6x. So we have minus 6x. Okay, so minus 6x, all right? I hope it's clear. So let's finish up here. If you look at this here, the numerator and denominator has a common factor, which is 3. I can actually factor out 3, yeah? Here, I can have this as dy dx equals to 3 in bracket 2y minus s² divided by 3 in bracket y² minus 2x. So 3 can go with 3. dy dx becomes 2y minus s² divided by y² minus 2x. This is our final answer. So put this down as a final answer. All right. We have a question that says, find dy dx for this y sine x equals to s² plus ln y. Okay, let's look at how we can solve this. Okay, don't forget that anytime we differentiate sine x, the result is cos x. When we differentiate ln y, the result is 1 over y, right? 1 over y. But in this case here, since we have y as a function, it means that I will multiply with dy dx after differentiating ln y. So let's go. So here, we're going to have here, we keep y constant. I will differentiate this in form of product rule. This product rule, y represents our a, sin x represents our b. So let's go. Let's differentiate this side. We keep y constant. Differentiate sin x, we have cos x, right? Plus, we keep sin s constant. Sin s constant. Differentiate y, we have 1. But in this case, since we differentiated y, I will multiply with dy what? Dx, or I will just add up dy dx. All right, so this is equals to, I will differentiate s², we have 2x, plus differentiate ln y, that will give us 1 over y dy dx. Don't forget that ln is a function in y. So anytime we differentiate y, we multiply the results with dy dx. So that's why I have to multiply this with this. But the derivative of ln y is definitely 1 over y, right? Okay, so let's finish up this. So here we have y cos x plus sin x dy dx equals to 2x plus 1 over y dy dx. So I will take these two as like terms because we want to look for dy dx. So let's find dy dx. So I'll group these two together as like terms. So that will give us sin x dy dx minus 1 over y dy dx equals to 2x. But we'll move this to the other side. It becomes minus y cos x. So I will factor out dy dx because our goal is to find dy dx. When we factor out this, I'll be left with sin x minus 1 over y equals to 2x minus y cos x. Okay, so let's go. The next is to, we divide both side by this. This will give us, divide both side by sin x minus 1 over y divided by sine x minus 1 over y. The y dx equals to, we have 2x minus y cos x divided by sine x minus 1 over y. Okay, so we can either stop here, or I can decide to also multiply both the numerator and the denominator by y, just to cancel out this term here. Okay, I can start to multiply both the numerator and the what denominator by what, by y, or I can just stop here. Okay, I can just stop here, but let me multiply through and see, or I can multiply through by what, by y. That will give us the y dx. If I'm to say multiplying this with y over y, right? Multiplying this with y over y is still the same as 1, all right? Okay, so why am I doing this? It's just to cancel out this 1 over y from here. So let's see what will be the result here. I'm going to have here as y times 2s will give us 2sy. 2sy minus y times y will give us what here? Y squared cos x, right? Divided by y times sine x will give us y sine x minus y times 1 over y will give us 1. So this can also be the final answer. Either you stop here or you stop here. Okay, so let's proceed. Okay, let's look at this equation here that have to do with implicit function under tangent line. Okay, equation of a line. We are asked to find the equation of the tangent line to the curve. This is the curve given to us at the points 1, 2. There's a formula that says we have the equation of a line using the point slope points. The point slope formula, rather. The point slope formula. The formula says y minus y1 equals to m1, or we can just say m bracket x minus x1, right? Where m represents the slope of tangent, all right? Or we can use m1 here. It means my m1 represents the slope of tangent. If the question says find the equation of the normal line to the curve, for normal line to the curve, I will still use the same formula, but in this case, I will find the slope of normal. The slope of normal is m2, but you must have to note that the product of the slope of tangent times that of normal is equals to -1. So to find the slope of normal, m2 is equals to -1 over what? Over m1. All right. So for this, see, question says find the equation of the tangent line to the curve. It simply means I will use this to solve, right? To solve. But in this case, I will use my m1 as the slope of the tangent. But if the question says find the equation of the normal line, and not same as tangent line, all right? Normal line to the curve, I'm going to use my m2 instead of my. It means I will replace this with what? With my m2. And m2 simply means -1 divided by what? m1. So using the point slope formula, we're going to use this formula to solve for the equation of the tangent line to the curve. So let's look at this together and see what we're going to do. So that means that before we can solve, we are given a point, right? Our point is 1, 2. That implies that our s1 is 1, our y1 is 2, but we have to find the slope of the tangents. It means I have to differentiate this. After differentiating this, any function that we have, we put in our x and our s and y to get the slope. Then we can find the equation from there. Let's see how to solve this. This is very simple. So what we have to do first is that we have to differentiate the function. Differentiating the function. We are solving now, solution. Let's differentiate the function. I'm going to use implicit function, but when we get to this point, I will use my product rule of differentiation. Don't forget. So for this, if I'm to differentiate my x squared, that will give us 2x, right? Plus, let's apply the product rule here. I will keep y constant. I will keep s constant, right? Differentiate y, we have 1. So we have the y, the what? The x. Plus, I will keep y constant and differentiate x. I also have 1, right? But I will not add my dy dx. I repeat again, differentiate x squared, we have 2x. On this side, we have sy. A represents x, b represents y. So I'll keep s constant. Don't differentiate x. Differentiate y. When differentiate y, we have 1. Because the power is 1. Okay? So we have 1. Then multiply with dy dx. Plus, keep y constant now, y. Differentiate this s, we have what? 1 again. But the difference between these two is that in this side here, we are differentiating y. That is why we are multiplying with dy dx. So let's proceed. So on this side, we have y squared. That will give us 2y. Then I'll multiply with dy the what? The x. All equals to, when you differentiate 7, the answer is 0. So here we have 2x plus x dy dx. Okay, plus y plus 2y dy dx, all equals to 0. So let's bring these two together as like terms. So we're going to have here as x dy dx plus 2y dy dx equals to, I'll move 2x and y to the other side. That will be minus 2x minus y, right? So our goal is to find our slope, which is our dy dx. So we have the y, the x as common factor. What remains here is x plus 2y equals to minus 2x minus y. So what do we do next? To find the y dx, I have to divide both sides by s plus 2y divided by x plus 2y. So this can go with this. We are left with the y dx, which can also be represented as m. We use m to represent slope. The y dx simply means slope. I hope you are aware. So this means our slope, which is same as what? Minus 2x minus y divided by s plus 2y. Don't forget we are given a point here. The point is 1,2, right? I guess it's 1,2. Yes, 1,2. So let's put in our value. So our slope becomes minus 2 times 1 minus 2 divided by 1 plus 2 times y is 2, right? Hope this is clear. Here we are putting in the value of x. Our x is 1. So anywhere we see x, we put 1. So minus 2 times 1 minus our y is 2. So minus 2 divided by 1 plus 2 times 2. This will give us minus 2 times 1 is minus 2. So minus 2 is minus 4 divided by 2 times 2 is 4 plus 1, 5. Then also recall that for point slope formula of an equation for a straight line, we say that y minus what? y1 equals to what? M bracket s minus s1. Okay, some textbook, we can decide to put m1 here. M1, likewise, like I said, M1 represents the slope of what? Of tangent line, right? Okay, so let's put in our value. We have y minus, our y1 remains 2 equals to, our M1 is minus 4 over what? 5 in brackets. Here we have x minus, our S1 is 1. So let's finish up this. Here we can expand the bracket. We have y minus 2 equals to minus 4 over 5 times x will give us minus 4x over 5. Minus 4 over 5 times minus 1 will give us plus 4 over what? 5. So we can decide to move this number to the other side, our goal now is to make y the subject. Our goal is to make y the subject of the formula. It means I'll move this to the other side, and that will give us y equals to minus 4x divided by 5 plus 4 over 5 plus 2 over 1. So we have y is equals to minus 4s over 5 plus the LCM between these two is 5. 5 into 5 will give us 1. 1 times 4 is 4 plus 5 into 1 will give us 5. 5 times 2 will give us 10. Right? Okay, so here we have y is equals to minus 4x over 5 plus 14 over 5. This is the final answer here. The equation must be of a straight line. The general form of a straight line we know is y equals to ms plus c. By the time you compare this, you're going to notice that our intercept rather is 14 over 5, but the slope must correspond with this slope here. What's our slope here? Minus 4 over 5. When you compare it with this, the slope here is what? Minus 4 over 5. So anything you are generating from here as a slope must correspond with the slope of that tangent. Do you understand the concept? Must correspond. Okay? If this is not corresponding, that means you are wrong somewhere in your calculation. That is just it. So this is just how to find the equation of the tangent. But if the question says find the equation of normal line, you know what to do. You have to find your M2. You have to find your M2. And I gave us connection between M1 and M2. We say that for that of normal, slope of tangent times slope of normal is equals to minus 1. So that means our M2 equals to minus 1 over what? Over M1. So what do we do here? To find M2, that will now give us minus 1 over. Our M1 is minus 4 over 5. Minus 4 over 5. Right? Minus can cancel minus from here. Inverse of 4 over 5 will now be what? 5 over 4. So that means to find my equation of normal, I will repeat the same process. I will use the same formula here, rather, to solve for that of normal. But in this case, I will change my M1 to what? To M2. It means anywhere I see M1, I will now put M2. And what's our M2 there? 5 over 4. That is just how simple this equation is. So sometimes in the exam, or they will not give you tangent. They will tell you find the equation from the normal line to the curve. Are you there? Find the equation of the normal line to the curve. Let's solve more examples. Okay, let's look at this question that says find the square y over the s², or is also pronounced as the 2y over the s². Anyhow, the square y over the s² of the function s² plus y² equals to 16. Anytime you see this simply means second derivative, okay, of a function. If f of x, all right, is equals to y, all right, and we also find dy dx. Dy dx is also same as y prime, right? We can also have what we call the square y over the s², which is same as y prime prime. For this is also same as f prime of x, right? This is also same as f prime prime of x. Okay, then the third one is the cube y over the s cube. Okay, this is same as y prime prime prime, which is equals to f prime 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 of x. We call this first derivative function. We call this second derivative function. We call this third derivative function. Meaning, by the time we find the first, we have to further differentiate to get a second. For example, if I have y equals to, let's say, 2x to the power of 4, and we also find, number 1, the y dx, number 2, the square y, the s², number 3, the cube y, the s³. To find this simply means the first derivative, I have to differentiate the first derivative. I will differentiate this first. That will give us 4 times 2 will give us 8x to the power of 3. Right? To find this, it means I will further differentiate our 8x to the power of 3. Are you there? And that will give us 3 times 8 is about 24, x to the power of 2. To find this will give us, this is the third derivative function, meaning 2 times 24 will give us 48x. Are you there? If there is fourths, it means by the time we further differentiate this, we have 48. So when you hear the word dy dx, it means first derivative. The 2y, the s square means what? Second what? Derivative. The 3y, the s cube means third derivative. Some people pronounce this as d²y. Okay, some call it d2y over ds squared. But the most important gist here is that this means first derivative, second derivative, third what? Derivative function. Okay, but as time goes on, we'll look at how to apply this in linear motion, right? If we also find acceleration of a particular function, and maybe we are given displacement, it simply means I have to find my second derivative if I have a displacement function and there's a find acceleration at a particular time. It means I have to differentiate first. That will give us velocity, right? Now on further differentiation, we're going to have acceleration. So acceleration falls in under second derivative function, right? While velocity falls in the first derivative function. Okay, so let's proceed and see how we can solve this question together. Now let's solve this question together. Then we round up with the last example. Here we have to find the square y or the 2y over the s square of the function, meaning I have to find the first derivative, then find the second derivative function. All right, so let's see what will be the result of this. Here we are given the solution. The first thing we need to do is to find the first derivative, which is our dy dx. So in this case, I'm going to use the implicit function, right, method, right? The rule that says that anytime we differentiate y, we have to multiply or add up with dy dx. So let's differentiate x squared. That will give us 2x, right? Okay, plus 2y dy dx equals to differentiate 16, we have 0. So I'll move this 2s to the other side. We're going to have here as have 2y dy dx equals to minus 2x. Okay, so to solve for that, to find dy dx, we divide both sides by what? By 2y. By what? By 2y. So 2y cancel 2y. We are left with dy dx, which is equals to minus 2 rather. We cancel 2 from here. We are left with minus x divided by y. This is the first question, the first answer rather. But the question says find the 2y over the s squared. Now there's a rule called the quotient rule of differentiation. The quotient rule of differentiation. You know, we have seen the product rule, right? If I have quotient rule or quotient function, like for example, if I have y equals to a divided by b, how do we differentiate a function like this? Like we just saw, minus x over y, this quotient. Quotient rule says that if y equals to a over b, the y dx is going to give us, I will keep b constant, differentiate a, the a dx, minus, in quotient we use minus sign, minus, we keep a constant, differentiate b, the b dx, then divided by b squared. This is totally different from product rule, right? It is different from product rule. This is not same as product rule. In quotient rule, we keep b constant, we differentiate a, minus keep a constant, differentiate b, then divided by what? B squared. But in products, what do we do? If I have a function, if I have y equals to ab, we are saying that the y, the x will give us, we keep a constant, differentiate b, we have the b dx plus keep b constant, differentiate a, the a dx. Are you seeing that the quotient rule and the product rule are not the same? So they are totally different from each other. So just take note of this. So let's apply the rule here. So using quotient rule of differentiation, right, to find second derivative, which is our d²y over dx², right? To find second derivative. So let's see what will be the result. So let's go. Here we have our d²y, dx². Or rather, let me just take up this. So let's apply quotient rule here to find the second derivative. So we have d²y dx². The rule say we keep y constant, right? We have y. Differentiate x. I'm going to have -1 here. We keep y constant. We differentiate minus x. We have -1, right? Minus. We want to keep y constant now. We keep minus s constant. Minus s constant. Then differentiate y. That will give us 1 dy dx divided by y². I repeat again. Why do we have to bring in implicit here? Because we have both x and y, right? In this function. So both x and y are acting as subject of this function, of a given function. Okay, so we have to apply the principle of implicit function, right? Yeah. So let me repeat this again. We actually kept y constant, differentiated minus x, that gives us -1. Then the rule of quotient says once you keep this constant, differentiate this, you put a minus sign here, right? Then we keep y constant now, minus s constant. When you differentiate y, we have what? 1. All divided by what? Y². This is the quotient rule of differentiation. So yeah, we're going to have here as d²y over dx² equals to minus y, right? Minus times minus will give us plus. So we're going to have plus x dy dx all divided by y². But recall that dy dx we solved. The answer is what? Minus x over y. So what we do is to replace what we have here with this. It means anywhere we see dy dx, I will replace with minus x over y. So that will give us here, we have d²y over dx² equals to minus y plus x times minus x over what? Over y. Right? So this will give us, okay, we have this already, all divided by y². So we have d²y dx² equals to minus y minus s times s will give us minus s², right? Over what? Over y. Okay, of course, all divided by y². I'll repeat again. Minus x, this x times minus x will give us what? Minus s². Then this is over 1. This is like saying s over 1, abi? So this times this will give us this. 1 times y will give us what? Y. All right, so let's proceed. Let's finish up this. So here we have d²y over dx² will give us, yeah, I can decide to take my LCM here. LCM between 1 and y, is definitely y, right? So if I'm to take this LCM as y, divide y by 1, that will give us y. Y times minus y will give us minus y², right? Okay, let's go again. Divide y by y, that will give us 1. 1 times minus s give us minus x, minus s², right? Okay, this is divided by y². I hope this is clear. Here we collected the LCM here. Between 1 and y, the LCM is y. So divide this y by 1. We have y. Y times minus y is minus y². Okay, the same y divided by y will give us 1. 1 times minus s² is minus s². Is that clear? Then we have a division here, which is this, divided by this y². So that will give us our d²y over dx² equals to, okay, yeah, I can factor out minus sign as a common. Here becomes minus y² plus s², all divided by y, times 1 over y². Okay, so let's finish up this. So we have the 2y or the square y over the s² equals to minus y² plus s² over y times y² is y³. I can also rewrite this as minus s² plus y² divided by y³. This can be, I can write this y² plus s² is same as s² plus y². Why I have to rewrite this? Because already we know that from the equation itself, originally we are told that s² plus y² is equals to 16. That means I can replace this with what? With 16. So we have here as the square y over the s² is equals to minus 16 divided by y³. Final answer. Minus 16 divided by y³. This is the final answer. Okay, we have a function that said find the y dx of y² minus 3xy² plus s² equals 2. Okay, definitely this should be implicit function, right? So what do we do here? We have to apply the rule of implicit function. So let's go. Solution to this. Let's differentiate y². We have 2y. The rule says multiply with the y dx, right? Good. Now in this case here, this other term, I'm going to use product with here. Here we have minus 3sy². So I will take minus 3s as a, then take y² as what? As b. I repeat again, I will take minus 3s as a, then pick y² as b. So let's go. So this will give us, using the principle we have, we keep what constant first. This is our a, right? This is our b. We keep a constant, meaning minus 3s constants. Then differentiate y². That will give us what? 2y. We have the y, the what? The x. Plus, we keep what constant this time around? We keep y² constant, right? Differentiate. We then differentiate minus 3x. That will give us minus 3. Okay, we are done with this. I repeat again. Using the principle of product rule of differentiation, we keep 3s constant, minus 3s constants. We keep a constant, differentiate b. So this is kept constant, right? When differentiate your y², we have 2y. Then because we differentiated y, I have to multiply with the y dx. So plus, we have to keep what constant now? y². Then differentiate minus 3s. The answer is minus 3. Let's come to this side. Plus 2x equals to 0. So this and this are like terms, right? So let's take them together. We have 2y, the y dx, minus 3x times 2 will give me minus 6. Minus 6 xy dy dx minus 6 sy dy dx. Let's go again. 3 times 2 is 6. Minus sign is here. Here we have y. Then we have our dy dx. So minus 3 times y² is minus 3y² plus 2x equals to 0. So between these two, I will factor out dy dx. In brackets, we are left with 2y minus 6sy, right? Then I'll move these two terms to the other side. This will give us 3y² minus 2x. The next is to find the y by dividing both sides by this, right? I'll divide both sides by 2y minus 6sy. This is 2y minus 6sy. So this can go with this. We are left with dy dx equals to 3y² minus 2x divided by 2y minus 6sy. So final expression can be dy dx equals to 3y² minus 2x divided by, between these two, what is common is 2y is common. Then we are left with y 1 minus 3x. 1 minus 3x.